Watch what happens when I append to copy only. Let's say copy.append and let's append 4. Right, then run it. Wait, what just happened? I only appended to copy, but original changed to. This is the bug that destroys beginner projects. Hello world! Remember the last video about strings? We noticed something rigid. Strings are locked. Once they're born, they're frozen. Today, the complete opposite. Lists, ordered, indexed, and 100% mutable. You can add to them, shrink them, reorder them on the fly. That freedom is why they are powerful and why they are dangerous. Your social feed, a list. Your browser history, a list. Your conversations with ChatGPT, a list of messages. Today, 3 things. What lists really are under the hood, how to use them in Python, and the trap that breaks beginner code constantly. Let's get into it. A list is a sequence of values. Wrap them in square brackets separated by commas. Numbers, strings, mixed types, and even other lists. Python doesn't care. Each item has a position 0, 1, 2. Index just like strings. But here's where the strings end. Lists can change. You can replace the values, insert new ones, delete old ones, reorder everything. Why? Because they exist for things that change. Think of a shopping cart. Items go in, items come out. A to-do list, a message queue. These are systems that move. Mutability isn't random, it is intentional. Quick mental model. When Python creates a string, it allocates exactly the memory needed. That is why you can't change it. Lists are different. Python reserves extra space ahead of time. If your list has 3 items, it might reserve room for 8. That is why .append feels instant. Space is already there. When the reserve fills, Python quietly grabs a bigger block. You never see it. It just feels fast. Lists are containers that grow. Strings are values that don't. So that is lists. Ordered, indexed, mutable. Built for systems that change. Back in Python, let's do some coding. First of all, let us create lists.py by saying touch lists.py. There we go, created, and let's work inside. Let's create languages. A list, let's say Python, JavaScript, Rust, and go. Let's print the languages, and then let's print the length of the languages. Alright, run it by saying Python lists.py, and voila. A list of 4 programming languages. Same length function we used on strings. Both are sequences. So how about some indexing and slicing? As you can remember, they worked on strings, so how about on lists? Let's try them. First of all, let's code this out. Let's say print languages 0 index. It should be, as we know, Python. And then let's go ahead and print the, let's say, index 2, which is the third one, should be Rust. And then let's go ahead and print the last one by saying, as you can remember, the last one, we said the negative first index is the last one, and that should be, as you can see, go. And let's go ahead and slice the list by saying print languages. Let's slice it from the beginning until the third, and let's say it should be the first 2. Okay, let's save it and run it. So position 0 is the first one, negative 1 is the last one, and slicing works same as strings. Everything you know about string indexing works on lists. Now, the part that makes lists different, changing in place. Let's code these out, and then let's try to change it by saying languages index 0 equals, let's say, C++, and then let's print the languages. Save it and run it. So as you can see, no error like the last time. The list changed. Strings can't do this, but lists can. So let us go ahead and learn the 4 operations that we will use forever. First, the append. Second, the insert. Third, the remove. And fourth, the pop. First of all, let's add a language to the list by saying languages append, and let's add Java. That means adding to the end, and then let's say languages dot insert, and then let's insert as the index 0, which is the first one, and let's say C, that is adding at the position that we choose. And then let's go ahead and remove one by saying languages dot remove, and let's remove JavaScript. That means deleting by value. And then lastly, let's say last one equals languages dot pop, and this means delete plus return. First of all, let's take it to the end because we want the codes to be executed, because Python reads from start to end. Let's try them one by one, saying first of all, let's clear, and then let's go ahead and try. As you can see, it appended Java. Let's go ahead and try this one by running again. As you can see, it added the C to the index 0. Now let's try the third one by Python list.py. As you can see, it deleted the JavaScript. And then finally, let's try the last one, pop deletes and gives the value back. Master these four and you can do almost anything with a list. Next, let's see sort versus sorted. Let's clear these out first. Let's clear the terminal too. Let's say numbers equal a list, like I said, 5, 2, 8, 1, let's say 9. Numbers dot sort. Let's try the sort method. This mutates in the place. Let's say result equals sorted, pass in the list we created, numbers. And this one returns a new list. Let's save it and run it. So as you can see, dot sort mutates the list and dot sorted returns a new one. One mutates, one replaces. Okay, now let's try looping. Let's create a list of countries. Let's say and France, and then let's say Italy, and say Iran. Finally, let's say India. Okay, that is a long list and enough. And then let's create a for loop for country in countries. Let's print the country. So let's save it, run it again. Read it like English. For each country in countries, print it. It's simple. But in the cases we need the position to, we will use enumerate. Position and value together. For that, let's say for I country in enumerate countries, let's say print I and country. Let's clear it, code these out, and then let's save it and then run it again. So as you can see, we got the positions too. So okay, one more tool. I think every Python developer uses this every day. Let's code these out first. Let's just leave the numbers and then let's first of all give the long way. Let's say the long way squares equals to an empty list, and then let's say for n in numbers, let's say squares dot append, and then let's pass in n times n. This is the long way, and then let's see the Pythonic way. Let's say squares equal n times n or n in numbers. That is beautiful. Clear it first, and then for comprehension, let's try them one by one. First of all, let's try this. They're both the same thing, but let's say print the squares. Save it, and then let's run it. So as you can see, this is the long way, and then let's use the Pythonic way. Save it, run it again in just one line of code. 5 lines collapsed into one. Read left to right. N times n for each n in numbers. So let's go even further by saying evens equal to a list, like I said, n for n in numbers if n percent sign means divide by 2 equals to 0. We added a filter at the end, took each n, keep it if it's even. Clear the terminal, and then let's say print evens. Alright, let's save it and let's run it again. And as you can see, we only keep the evens and got rid of the other ones. This is how Python developers think: compact, readable, and fast. Now the bug that catches every Python beginner. Get rid of those and then clear the terminal too. Let's say I want to make a copy of a list. Most beginners try this. So first of all, let's create a list to begin with. Name it the original equals the list 2, 3, and then let's go ahead and make copy, and let's say it's equal to original, and then just to show it, let's print them out by first saying original. This is not our variable, a string, and then go ahead and type in our variable, copy the same, print copy. Okay, so let's save it and run it by saying Python lists. There we go. Looks fine. Same numbers, 2 variables. Looks like a copy. Now watch what happens when I append to copy only. Let's say copy.append, and let's append 4. Right, let's save it and run it. Wait, what just happened? I only appended to copy, but original changed to. This is the bug that destroys beginner projects. Hours of debugging, confused tickets, production incidents, all from this one line. So here's why. A variable in Python is just a label, a pointer, not the box itself. When you wrote copy equals original, you didn't make a copy of the list. You made a second label, pointing at the same list in memory. Both labels see the same data. So when copy mutates the data, original sees the change too. Because they were never 2 lists. They were always one list with 2 names. To make a real copy, you have to be explicit. 3 common ways. First of all, let's code these out. Copy 1 equals original. Let's go ahead and slice it. We know this is slicing. Copy 2 equals list. Let's go ahead and pass in original. So this is called constructor. And finally, let's go ahead and say copy 3. This one equals to original dot copy. And this is called the method. So 3 different syntaxes, same idea. Each one creates a brand new list with the same values. To prove the fix actually works, let's mutate copy 1 and watch what happens to original. First of all, let's pass in a note and let's say mutate copy 1, add a value, change a value. Let's go ahead and say copy 1 dot append, and then let's append 99. Say copy 1 index 0 equals changed print original. Say say, and go ahead and pass the value, original. Same again, just to show it, let's say, print copy1, pass in copy1. Same with the others too, say copy2, and then go ahead and pass copy2. Finally, pass in a string as copy3. Alright, just to see better, let's make it bigger. Let's clear the terminal too. Run the script. There we go. I appended to copy1. I changed position 0 of copy1, and original, it's untouched. Copy2 and copy3, again untouched. Each one is its own separate list. This is what a real copy looks like. Each variable points to its own list. Mutating one doesn't touch the others. Strings give you safety for free. Lists give you power, but you have to manage the references yourself. So why does any of this matter for AI? Because every conversation with an LLM is a list. Let me show you exactly what that looks like. We start an empty conversation, just an empty list. First of all, let's clear them all and clear the terminal too. And let's create a list, and let's say conversation equals an empty list, and let's say print the conversation. Save it and let's just run it. And as you can see, it's an empty list, 0 messages. This is what your conversation looks like before you've said anything. The user types their first message in code. Each message is a dictionary. 2 keys, role and content. Let's say the user message equals curly braces, say role, let's say user, comma, and then let's say content, and let's pass in I. Let's go ahead and append it to the original conversation, saying conversation.append, then pass in the user message we created, save it, run it again, and voila. 1 message in the list. Role is user, content is hi. We use .append, the same method we learned moments ago. The model response, same shape, dictionary with role and content, but role is assistant now. Let's try it. Let's go ahead and pass in the assistant message. It equals to curly braces. Let's go ahead and again say role, okay, assistant, comma, let's pass in the content. This time, let's say hello, how can I help? Let's go ahead and say conversation.append, and let's append the assistant message. Save it and run it again. 2 messages now. The list grew. User asks a follow-up. Let's say follow-up equals, again curly braces, say role, again let's say user, comma, say content. This time let's pass in tell me about Python lists. Again go ahead and say conversation.append, and this time pass in follow-up. Save it, run it again. 3 messages, and every time someone sends a new message, it's just another append. That's it. That is the entire structure. A list of dictionaries, growing 1 append at a time. Every time you talk to GPT, Cloud, Gemini, or any other model, this is the data structure on the server. And when you hear the term context window, here's what it actually means. How long can this list grow before it's too big to send to the model? That is the limit, not the number of words, not the number of characters, the length of this list of messages. Once it gets too long, the system has to drop old messages, which is why the long chats start forgetting what you said earlier. The list got too big. Old items got popped from the front. Lists are how AI remembers, and lists are how AI forgets. Master 4 operations: append, insert, remove, pop. You can do almost anything, but never forget the trap. A variable is a pointer, not a bug. Mutate one reference, and every other reference sees it. Strings protect you. Lists empower you. Engineers need both. Knowing the syntax is useful, but understanding the right tool for the job is what makes you a problem solver. In the next video, still in Series B, lists inside dictionaries, dictionaries inside lists, real-world data modeling. I'm Hex1000, logic behind the code, signing out.